Hello everyone, welcome back to the channel. Before we start this session, let's create a separate branch for this tutorial. Let's name this branch tutorial. We'll create a separate directory by the name of data structures, and inside that we'll create a file by the name of tutorial. Okay, so in the last video, we learned about variables and how to store single piece of data inside a variable. For example, port is equal to 22 or a string inside a variable IP. But in the real world of cybersecurity, we don't just deal with one IP address. You deal with logs containing thousands of IP addresses. If you try to create 10,000 individual variables, you will lose your mind. You need a way to organize, group, and manipulate massive amounts of data all at once. Welcome to video 3. Today we are opening the armory and looking at Python's data structures. We have 4 major data structures: list, dictionary, tuple, and set. First, we have the list. It is used to store multiple items in a specific ordered sequence. To create, we need square brackets. As you can see, we use square brackets to create an empty list. Then we printed that list, which in this case is empty. And if we check the type of this variable list_1, we can see it is of a class list. Now since we know how to define a list, let's go ahead and define some real values inside it. Before doing that, let's comment this section. Let's take a variable by the name of IP address and store some IP addresses inside it. Here you can see inside the variable IP address, we have stored 3 values. In a different scenario, we might have to create 3 variables to store all these. But with the help of list, we can do that inside just one variable. Now, to check the length of this variable, for example, length of this list, we can simply use the function If you just type len for length and then your variable, you can see the length comes out to be 3. Now one more question we want to address here. You can see we stored all strings inside this variable, but there is no limitation to the type of variables you can store. You can have a combination of different types. For example, we can have a variable by the name of list_1 and we can store an integer, a float, and a string. All inside this. If we print it out, we will see the expected outcome 22, 7.5 and hello. Now if we move towards the core properties of list, the first property we have is of ordered sequence. Similar to what we had in string, lists are also an ordered sequence, which means we can index and slice specific sections of the string. Let's take this one for example. So what we try to mean is, if you just print list_1 and use the same notation, a square bracket notation, to index the variable. We discussed in the last video the indexing starts at 0, 1 and 2. So if we type list1 square brackets 1, we are expected to see the outcome of 7.5, which we saw in this case. Similarly, for the slicing, we can use the square brackets start and then stop and then step if that is required. And if we print it out, we are going towards 7.5 and hello. The second property we have for list is of mutability. If you recall our last session on strings, strings were immutable. That is, once you assign a value to a string, we cannot change it. But in the case of list, lists are mutable. So if we want to modify this 7.5 to 8.5, we can do that. We can do list1 and then index the first variable and change it to 8.5. Here you can see the first index have been modified, which proves the property of mutability. Now let's talk about some methods that we have for list. We will start our discussion with the very basic of append and pop. And as the name suggests, they are used to append some values to the list or pop some values out of the list. For example, let's comment these out. We have this original list. Let's say we want to add an integer value of 90 to the end of the list. What we can simply do is now you can see the 90 has been appended to the end of the list. Similarly, now we have this list again. Similarly, if we have to pop out this hello, we can simply write as you can see, now we have only two values since we have popped out hello. Now the popping also works for specific index. For example, if you want to pop out this 7.5, you can use the index value of 1 and then we will have 22 and hello and the 7.5 has been popped out. Let's comment these out. The next method we are going to talk about is insert. And yes, as the name suggests, we can insert some values at any specific index using this method. So if we do list_1 dot insert, we have to mention with which index. For example, we want to insert some value after 7.5, which means 0, 1, 2. So if we have the index of second and the value, let's say we have is something. Here you can see we have that something added to the second index. This is how the insert method works. The next methods we have are of sort and reverse, and they are pretty self-explanatory also. But there is a limitation, which is a logical limitation. We can't run that on this case since it has a string as well as an integer values, a number values. So of course it will print out an error. So if we simply run this, you can see not supported between instances of string and float. So what we will do is we will just comment it out and we will use a different string. We will use a different list. Now if we run the list1.sort and print out our list, you can see the list is sorted. Similarly, if we want to reverse this list, we can use the reverse method. Here you can see originally it was 1, 89, 23, 56, 12. Now it is 12, 56, 23, 89 and 1. So those were some methods related to list. Next, we are going to talk about dictionary. A list is just a row of data, but dictionary maps a key to a value. We use curly braces here. So to define a blank dictionary, we can simply write dict and two blank curly braces. Now if we just print the type we have for this variable, you can see it is of the class dict. Why would we need it? So let's say we want to map usernames with their access level. It's a real world scenario. For example, we have a user 1, let's say Kunal, and he has standard access. And we have a user 2, let's say Mukul, he has admin access, and so on, so on. To store all this in a single variable, we can use mapping. We can use key value pairs. For example, we can create something like access level variable, and then we can type the name, and then we can type the access, in this case, which was standard. So this is a dictionary. So here we have a key, then we have a value. We have a key and then we have value. So we can do mapping inside this data structure. Now if we want to know what level of access does this user have, we can simply reference the key here using the square brackets. So for example, for this user, Mukul, if we want to check what was the access level, you can get the value of admin. Also, if you want to append some values at the end of this, what you can do is you can call the variable, and in the square brackets, you can add the new key, which in this case would be a new name. And then you can assign it the value. In this case, let's keep it again standard. And let's print it out. So here you can see the output. Now we have 3 entries inside this dictionary. The next concept we are going to talk about is that the keys inside a dictionary always stay unique. So if I try to assign something like So instead of appending one value at the end with this key and this value, since this key already exists inside this dictionary, it will modify the existing value and make it the new value. So if we print this out, you will see that the previous value of that key has been modified to admin, which proves the concept that keys inside a dictionary are unique. Now let's talk about some properties for dictionary. First we have is that dictionaries are unordered. Since lists were ordered, what we were able to do was we could index it, or we could sort it, or we could reverse it. But dictionary can't be sorted and they can't be indexed. So if you try to do something like zeroth. So if you're trying to reference the zeroth element here, hoping that you will get this output, you will get an error. And the error says, okay, it only says key error 0. But the point here is that there is no ordering here. You can't reference the zeroth value. The second property that we have is that dictionary has mutable values, which means you can modify the value, like the example we did previously. So we had this value, this key had the value of standard, and then we modified it to a value of admin and we printed it out and it worked well. That proves the concept that the values inside a dictionary are mutable. And the third property we have is that keys are unique, which we also proved a couple of minutes back. by trying to assign this variable a value of admin, which modified the last value instead of appending a new one. Now let's talk about a couple of methods here. We're not going to dig deep into a lot of methods, but the very basic ones are keys, values, and items. So what these do is, let's comment it out. If you try to print access level dot keys, as the name suggests, we will be getting output of all the keys, which is Kunal, Mukul, Ritik in this case. If you try to print values as expected, we will get the access level, standard, admin, and standard. And finally, if you print the items, you will get both in the form of a tuple. Okay. One last concept before we move towards the next data structure is that you can nest things inside the data structure. We did not cover that in list, but you will get an idea what we are talking about in this dictionary. So you can have something like, let's say key 1, and you have some value 1. Then you can have something like key 2, and let's say you have a value of, let's say you have list inside it. So you can nest a certain data structure inside another data structure, or even without a list, you can have something like K1, V1, and then K2 and V2. So that is valid. Let's try to understand it with an example. So what we did previously was this. Let's comment it out, comment this, and comment everything. Okay. Now let's suppose that there is a third user, which in this case, let's keep this. And instead of just having standard or admin, that user has 2 or 3 level of accesses. Let's say he has power access and also super admin. Okay. Now, if you want to print access level and then so now you can see you print this. Now you might be wondering, what if I want to reference this one? Since this is a list, it sits at index 0, index 1. So if I just add 1 at the end of this, we will get the desired output. Let's take a complex example. Let's assume we have a variable which contains key 1 with have a value of 1 to 3. Then it contains a key 2 which contains a list of 0, 1, 2. Then it contains a third key which contains another dictionary with a value of, let's name it inside key, and it has a value of 100. Now our aim is to reference this 100. So what we can do here is we can simply reference dict1. So now we are here. If we reference K3 here, we have reached here. And again, if we reference inside key, then we should get the output of 100. Yeah. So you can have nesting, and the nesting can be as deep as possible. And this is how you can reference the values inside a nested data structure. Okay. The third data structure we have are tuples. A tuple is basically a list, but with one massive difference: immutability. Once you create it, it cannot be changed, added, or modified. Let's take an example how to define it. You can define a tuple using round brackets. You can have 1, 2, or 3. Now, talking about the properties, the first property we have is immutability. As we know, immutability means that the values inside cannot be changed. So let's try to change it. Let's say tuple 1, and at 0th index we want to have the value of 5. Let's see what's the output we get. You can see we are getting an error. Why? Tuple object does not support item assignments. That proves the concept of immutability. Once you have defined a tuple, you can't basically modify it. The second property we have here is that tuple is a ordered sequence, which means similar to list, the values are ordered, they can be indexed, they can be sliced. So in this case, if you wanted to print tuple 1 second index value, you can get that, which is 3. Or even if you want to print a sequence, you can get 2 or 3. You can slice out of the tuple, you can get 2 or 3. So the immutability works in that order. But why you want a list you can't change? The main reason it could be to ensure integrity, to ensure nothing accidentally modified the list, it stays logged in. Finally, the last data structure we are going to discuss about is set. Unlike list or tuples, set are unordered, which means you can't index them, you can't slice them. But what makes set unique is that they don't allow duplicates. Let's take an example. To define a set, what we can use simple here is that let's take a variable by the name of set1. You can use a function by the name of set and pass some values to create a set out of it. Now it might sound confusing at first sight, but what it does is that you define set function and the argument you pass is, it could be any data structure by which you want to create set. This inside is a list. This is a list which contains 1, 2, 3, 4, 5, 6, 7, and using this list we want to create a set. So if you print the type of this variable that we have and also print this variable, you can see, okay, typo. You can see that this is of a class set, and when you output it, it also shows curly braces like we have for dictionaries, but in this case you'll see the values inside that set. Now, what are the basic properties of set? First, sets are unordered. So similar to dictionary, you won't be able to index it. So if you try something like print set1 first element and we run it, then we get that set object is not subscriptable. The next thing we have is the one we talked about in the beginning, that it does not allow duplicates. So what it means is, let's copy this. If you have something like this, and let's add some duplicates here, 2, 3, and 7. So you can see the length here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 elements. But if you print this variable, you will see that it only has the unique values. Now, similar to this, you can also use this structure to define other data structures. What I mean is that you can use something like list. You can say list1 equal to create a list from let's say 1, 2, 3, 4. And then if you print list underscore 1, you can have the list. So you can use something like this, methods like this, to convert one data structure into another data structure if that conversion is possible and certain parameters are met. So let's comment this out. The one method that we are going to talk about here about sets is the add. And as the name suggests, you can add certain values to the set. So let's take this set again. And as we saw that this set has value these, and let's say we want to add 29 at the end. So what we can do is set 1 dot append, and we can add 29. Let's also print it out. So here you can see, okay, not append, add. Okay, so here you can see the 29 has been appended at the end of this set. Imagine you have set 1, which has values 1, 2, 3, 4, 5. And then you have set 2, which has values 3, 4, 5, 6, 7, 8. Let's keep till 7. Okay. So now if you try set 1 minus, okay, set 1 minus set 2. What it means is we want everything which is in set A, but it is not in set B. If you run this, you can see the output as 1, 2. So we have 1, 2, which was in set A. So we got the output, but we also had 3, 4, 5, but we did not get that output because that values were present in set B. If you try set 1 or set 2, in this we will get all the values which are either in set A or set B. Here we will get everything 1, 2, 3, 4, 5, 6, 7. The third operation we have is set 1 and set 2. So we will get the unique values which are in both the sets, which in this case is 3, 4, 5. And the last operation, set 1 and set 2. You will get 1, 2, 6, 7. What it does is it prints out those values which are either in set A or in set B, but not in both. In this case, 3, 4, 5 are the values which are in both of these cases, 3, 4, 5, 3, 4, 5. So we are left with 6, 7 and 1, 2. Imagine you export a massive firewall log where attacker tried to log in 500 times using only few IP addresses. To extract the IP addresses, you don't need a complex filtering algorithm. Instead, you can just use set. To conclude, list for ordering, dictionaries for mapping, tuples for locking data, and sets for removing duplicates. These 4 are the core data structures of Python. There is no good or interesting exercise we could do just by learning these data structures, so we will skip that for this video. Regarding the code, it needs certain cleanup, so I will do that cleanup and push that to the GitHub repository, which I will also link in the description. Now that we have covered all basic data types and data structures, a script needs a brain to know how to make decisions. In the next video, we are diving into logic and control flow, if, else, and elif statements. Like, share, and subscribe to secure your feed, and I'll see you in the next one. Keep defending.